we have what are called these anomalies in space. These anomalies in space, which by the term itself alone suggests that an anomaly is the most scarce object in the universe. An anomaly is something you rarely find. That's why it's an anomaly. Oh my goodness, everything else is one way, but that thing is another. And we call that a singularity, Oh, singularity. All things are around it, but it's the thing that has no character and maintains this complete empty void of being anything at all. And it's not even a position, because all things are just around it, and they loop into an event horizon and sucks the information out, and it doesn't throw out any form of information for it to indicate anything. And these are black holes in the universe. But that position of a black hole, that observation of a black hole, might be a very near-sighted observation of a black hole, or rather a narrow-sighted observation of a black hole. Because the most farthest observation of a black hole, rather than the nearsighted. Now the nearsighted says, well, that black hole is just this empty nothing in space, not even space itself. And there's an event horizon, and this event horizon, nothing passes beyond this point, and beyond that is just the furthest object that is not being sucked by this thing, and that's just from there begins regular space and time and normal. Very far away from that are things very settled, and things are a certain way and they move in a certain motion. And furthest away from that, well, you get very, very far away from a black hole. Next thing you know, you're entering a different dimensional state of being, a different magnitude. See, you go furthest away from black holes, furthest away from galaxies and universes. And in these universes, you start seeing supernovas. And these supernovas are the furthest thing away from a black hole, but because it discloses a black hole, it discloses all the gas and every single content of matter that makes up anything in the universe. It discloses all that into a big, gigantic form. And like a galaxy, looks like a tiny point, just like a little like flash of a grain of sand in what we call stardust, where all stars originate from, we say. Stars are also, where everything originates, from in terms of life. And if you didn't figure by now, we ultimately take a star at one point from one level of its dimensional magnitude as to be the entire limit of an observable universe from an inverse position. It's like seeing the closest, furthest world to the observer. And that world is blocked by the brightest light emitting from itself. It's an entire beginning of a universe whose entire collective light becomes sucked into a discrete point, and from an opposite position becomes emitted infinitely. So it's the point where two parallel universes lie with one another. And a star, it's a certain break in that space-time fabric, and it's everywhere, and it's breaking through, and there's different magnitudes of stars, and there's one that's huge and one that's tiny, and like you get a sheet and you poke holes in it and you put it on into the sun, and then you see little lights coming out of the hole. It's like that, and beyond that, it's just a different universe. But then you operate, but you look at from the point of view of the fabric that is being punctured by different sizes of holes that all exhibit a different magnitude of energy, and you have that coming out from each side. And then from that point of view, go furthest away from those lights, and those lights become little discrete points forming some, unknown content, material content. And that's what we say is stardust. And then, if you go out, zoom out further into the universe, you see this stardust form, and it becomes this supernova, which is this spherical, gaseous, but then this living looking thing. It's some kind of organism. and it has an eye. It has like a center point, and the gas around it forms some kind of like an eye in the center of the space. Massive. You are just a speck, a little tiny little speck, an infinitesimal little speck of a speck forming one point on the circumference of a greater, bigger speck that is a sphere in a circumference forming a bigger object. And they're in this together, forming this vision, and it's observing, conceiving everything. And the supernova is what we call in science a wormhole. It's a portal in space. It behaves oppositely than its most discrete point, which is a star, we say, is reflecting and emitting the most amount of energy from a singularity point. The singularity is a void in space-time, a black hole where it sucks things and never takes it out. And from the inverse position, what we call a white hole, we say they're theoretical objects in the universe. No, they're not. They're stars. But we have no single characterizations of a white hole, so we can't just say, well, that's a concept. So we have a black hole as a concept, but white holes are just speculative ideas or concepts, I guess. But every star ultimately exhibits the nature of a white hole, which is just, it's infinitely throwing out energy. The connection between a black hole sucking in infinite energy and a white hole throwing it out. A white hole has to be the opposite of a black hole. But then we can't, but then it's not so dumb to say that, because we can't call stars white holes, because they're really all these different things that are very they have very peculiar differences. And these supernovas, I explained it in a section a few weeks ago, is a portal, because